Hey guys, welcome back to Helper Function. In this video we will discuss a popular question, subsets. So the problem statement says that given a set of distinct integers num, return all the possible subsets. Now all the possible subsets of any set is also known as a power set. And also there should not be any duplicate subsets in our answer. Now for this example, num's array contains 3 elements 1, 2, 3 and there are 8 subsets generated in total. We can see that the empty set and the whole set is also considered in our answer. And also the return type of our answer would be a 2D vector, where each vector represents a subset. Also it is given that you can return your answer in any order. It need not to be in sorted form. So let's see how we will solve this. For the array of size n, the total number of subsets generated would be 2 to the power n. This is because for every element we have two choices, either to take it in our subset or not to take it. Thus, taking this combination for every element, we can generate 2 to the power n subsets. Thus, by taking this idea, we can make a recursive function which for every index have two choices. First, either to choose the current element and second, not to choose the current element. Here's the approach how we will solve this problem. Initially, we will have an empty vector. Now for every index, we are going to perform these two operations. The first one is to ignore the current element and call the recursive function with current subset and next index, which means that we are not going to take it in our subset. And the other one is to insert the current element in the subset and call the recursive function with the current subset and next index. That is, we are going to take it. Now let's try and understand with example. Initially, we will have this empty vector. Now for index 0, we have two choices, either to take one or not to take one. The yellow box represents not taken part while the green one represents the taken part. So if my array size was only 1, these two were the subsets which I would have got. Now we will perform the same operation recursively for the next index. So this time our element is 2. So for this empty subset, if it does not count 2, it remains the same, otherwise 2 gets added. Similarly for 1, if we not count 2, it remains the same, otherwise 2 gets appended here. Now we will again perform the same operation for all these subsets for the last index. This time our element is 3. Similarly, every block will have same option. For the first part, it will remain same as it is, and for the other part, 3 will be added. Thus, you can see that we have got our all different 8 subsets. Now let's try and understand the code. We are given with the nums vector. We declare a 2D vector answer which will store our answer. Now temp is a vector that will store all the states. We are calling a find function which has 4 parameters. First is the nums vector, second is the temporary vector, third is our answer, and fourth is the index. So we will start with index 0. Now in this find function, this if condition is the terminating condition, which says that if our index has reached to end of the array, which means that we have got our answer and we will push our temp vector in answer and return. Otherwise, we have got two choices. First, we will ignore this element and just call this find function with increased index. Otherwise, we will push this nums of I in our temp vector and again call this find function. So from this figure, you can visualize that all these boxes that are generated are nothing but the temp vector. The yellow boxes are those function calls where we ignore the current element, while the green boxes are those where we count the current element. Also, at this level, we will reach the terminating condition and thus we will insert all these temp vectors in our answer. And finally, after all the function call, we will return this 2D vector as our answer. Now the time complexity for this problem is order of n into 2 to the power n. 2 to the power n to generate all the subsets, and order n for copying them into the output list. And the space complexity is also the same because we have to keep all the subsets of length n, since each of n elements could be present or absent. So this was all about the problem. I put the problem link in the description so you can go and solve it. If any doubts or suggestion, please write in the comment. Thank you for watching.